Okay, today we're going to be proving trig identities. The cool thing about this is you know the answer before you begin. It's all about proving the work you did to get there. So you must show every step along the way and hang in there. Got some advice for you, so watch closely. Two methods. Method one, start with either the left side or the right side and make it match the other side. So I'm going to do the left side, make the left side look like the right, or make the right look like the left. That's all there is to it. That's what we're going to use probably 90% of the time. However, there is a method two, which is work with each side separately until you obtain the same expression. I'll put that's the last resort. Working with both sides is the last resort. We want to work with one side as much as we can and make it look like the other side. However, if we can't do it, we'll work with both sides and see if we can make them both equal. But the bottom line is we want to show that one side of our identity is the same as the other side. Strategies. Number one right here says use method one or two, which we will always do. Work with the more complex side first. So look which side looks like the most difficult or the hardest, and let's go with that side. Number three, carry out all the algebra you can, add, subtract, multiply, divide, factor, any stuff that you can see that you can do it. Number four, if you have a fraction there, multiply by one to make the fraction go away, and I'll show you one of those later. Convert everything to sines and cosines is a great thing to do. We're going to do that a lot. If you get stuck, just change everything to sines and cosine. Number six says try something. Put your pencil to work and get involved. You'll be amazed how often this leads to success. In other words, look at this right here. Don't sit and stare. Sitting and staring. Even I've been doing this for years and years. Usually can't look at one and think, okay, I'm going to do this. Usually I have to start working, and the answer just shows up. And that's what you kind of got to do with these. Just start going. Okay. Here's what they look like. It says prove 1 plus sine 2x equals sine squared plus cosine squared. So I'm going to go with the right-hand side because to me it looks a little more complicated. So I'm going to square that, make that sine squared. Remember how you square things, you square the first. You multiply together, double. So I'm doing that now. And then I'm going to square the cosine. If my marker would write it. There we go. So what that gives me is I see a sine squared plus cosine squared. Do you know what that is? Anytime you have a sine squared plus cosine squared, that's 1. So I get 1 plus sine x cosine x. And guys, this right here, if you look at your sheet of identities, 2 sine x cosine x is sine 2x. That's what it is. So I'm just going to replace it with sine 2x, and I've done it. I've made my right-hand side look exactly like the left-hand side, and that's what you're doing today. Let's try another one here. I'm going to work with this side. It's more complicated than the other side because it's got subtraction. It's a lot easier to turn subtraction into multiplication than it is to change multiplication into subtraction. So that's how I'm going. I'm sorry about my squares there. Don't look very good. So I just rewrote that one. And anytime I have subtraction, I'm going to go ahead and do the subtraction. My denominator with fractions, you got to have an LCD. My common denominator is going to be cosine squared because that's my only denominator. I'm going to go ahead and bring down this first sine squared because it already has that denominator. The second one, if I'm going to put this sine squared over cosine squared, you got to multiply the top and bottom by cosine squared. And I'll show you a little bit of trick to do that tomorrow. So that's going to be sine squared cosine squared over cosine squared. So I'll basically just multiply this by 1 if you can see that down there. Okay, I'm looking at my numerator. They both have sine squareds. Both terms do. So I'm going to take out the sine squared or factor it out. That leaves me 1 minus cosine squared when I factor over cosine squared. Move this up in that room a little bit. Now, every time I see this, the 1 minus cosine squared, I got to remember that's really is sine squared. So I have sine squared times sine squared over cosine squared. Now I'm going to show you a little trick right here that you can use anytime you need it, and there will be times that you do need this trick. And that is this. If I have two things in my numerator that are multiplied together and only one term in my denominator, I can split those up. As in, I'm going to do sine squared over cosine squared like that times sine squared or sine squared over 1. And if you look at that, I just broke up that fraction into two different fractions. And everybody knows sine squared over cosine squared is tangent squared. And sine squared is sine squared. And if you look at what I have right here, look back over the top, exactly the same thing. I was thinking another one here. Really the best way to even show you this stuff is just like to keep showing you examples. And to be honest, it's hard to show examples of everything you're going to see, but just keep showing you some, and hopefully you kind of see what I'm doing, and we'll work on it tomorrow. First of all, just do what you see. Like I see sine 2x. You know, that's one we had a while back. Sine 2x is 2 sine x cosine x. So I'm going to write that over sine x. Cosine 2x, you have three options for that one. I'm going to go with a cosine squared x minus sine squared x. To be honest with you, I just chose one at random there. Could have picked any of them, and you know, who knows what would have happened. Probably still would have worked. So my first one right here, what I notice is that my sines will cancel. So that's just 2 cosine x is all that leaves. On this one, I'm kind of stuck here for a minute. Cosine squared x minus sine squared. If it was 1 minus sine squared or 1 minus cosine squared, obviously I'd change it. But the cosine minus sine squared, I'm still kind of stuck. I have subtraction now, and when I have subtraction, I'm going to find an LCD, which is going to be, told you earlier, I'm going to make one big fraction, make it cosine x. Now this right here is really 2 cosine minus over 1. So I'm going to pull the top and bottom by cosine x to put it over cosine x. So I'm going to rewrite it 2 cosine squared x minus cosine squared x minus sine squared x. My handwriting is getting really bad. Sorry, my stylus is kind of going crazy. I'll blame it on that. Now 2 cosine squared, the minus sign 2, when I'm doing that fraction, this minus sign right here actually subtracts that whole thing. That's important. So this minus sign, remember, changes all the signs. So I really have 2 cosine squared minus cosine squared plus sine squared all over cosine x. And when you know what I'm now kind of seeing what's going to happen. And what I see on the top is I see 2 cosine squared minus 1 cosine squared, which is 1 cosine squared. And I still have that plus sine squared over the cosine x. And, you know, every time you see cosine squared plus sine squared, you should think, oh, that's 1. 1 over cosine x, which is secant x, which is exactly what I was hoping to get. That looks a lot more difficult than it really was. It's just plugging stuff in, using identities you already have, changing things to sine and cosines, doing subtraction, and then watching it work out. All right, yet another one. This is secant t minus 1 over t secant t equals 1 minus cosine t over t. Now, one hint here, it's difficult to change a lot of cosines to secants, but it's easy to change secant to cosine. Remember, secant is just 1 over cosine. So I'm going to write it like that on the numerator and denominator, just like that. I'm going to take that left side and see if I can make it look like what I want it to over here on the right-hand side. So let's see what happens. I really have this. I really have 1 over cosine t minus 1. My marker there, I'm so sorry. On the bottom, if you multiply the denominator, I have this. I have t over cosine t. And now don't forget this. Anytime you have a fraction bar means divide. And divide means, you know, in your case, keep, change, flip, or just multiply by reciprocal. So I'm going to take the numerator right here, 1 over cosine t minus 1, and multiply it times reciprocal with my denominator, which is cosine t over t. And see what happens. When I do that, when I multiply the first term, the cosines would cancel. Let me see if I can do that for you. When I multiply that first term, the cosines, oops, wrong one. Cosines would cancel. So I would just get 1 over t. The second term is just 1, so I'd get the same thing, cosine t over t. And so my denominators are the same, and so I'd get 1 minus cosine t over t, which is exactly what I wanted. You know, stuff, it just happens. It just works out for you. It's kind of amazing. You just kind of don't sit and stare. You just kind of got to go with it. Okay, you need to stop this video, and this is your last, I promise, these are the last 8 of your identities that you can put on your sheet to use. I'm going to show you one problem using one of them, and the video will be done. All right, finally, our last slide. This one says find an identity for cosine x plus 5x, or simplify it. And we just didn't have one in the last slide. There is a it's called sum to product. And you can look at that and find out where it says cosine plus cosine. And what it says is cosine y plus cosine x. So I'm going to say this is my y, that's my x. I'm just going to go with it here. The identity said you do 2 cosine x plus y over 2. So it'd be 5x plus x over 2 in this case. And then cosine x minus y over 2. In this case, 5x minus x over 2. So all you do is add the top here. 5x plus x is 6x. Divided by 2 is 3x. Come to the second one, 5x minus 1x is 4x divided by 2, which is 2x. And guys, that's it. We made an identity. That right there does equal this according to the sum to product identities. And that's all you have to do on those. Actually, probably the easiest one we did all day. So, we'll work on these tomorrow, maybe a couple days if we need to. We just need to keep trying them and trying them and trying them. And eventually, I promise you, you'll start getting them. But just got to try stuff. Don't just sit there. And I'll see you in class tomorrow.